So what we're doing today is we're looking at solving exponential equations where a common base is not possible. I will remind you that if I gave you something like 27 to the 2x equals 81 to the 3x plus 4, you know how to solve that equation because you can use a common base. And before I do this as a review, it's very important for you to understand what we're going to learn today could be used to solve this type of equation, but you are asking for trouble if you do it that way. You always want to use a common base if you can use a common base. It makes things really easy compared to the alternative. So this would be 3 to the 3 to the 2x equals 3 to the 4 to the 3x plus 4, which would mean 3 to the 6x equals 3 to the 12x plus 16. How's my Monday morning multiplication and arithmetic? Okay. Now you would drop the bases, because if the bases are both 3 and these are equal powers, the exponents must be equal. And I'll leave it to you to, we're not going to solve that. You know how to solve that, right? You're going to subtract the 16 and subtract the 6x and end up with 6x equals negative 16 and go from there. So that's what you do if the bases are bases where a common base is possible. However, what we're looking at doing today is solving equations like that, where you cannot write this as a common base. That's what we're talking about. So, over the next couple of lessons, we're going to be looking at using everything that we've learned about logarithms and everything we've previously learned about exponents to solve a number of different equations, and the types of equations we're looking at today look like this. Now, this question is very simple, and you could solve it by just converting it into logarithmic form. Right? If I say 4 to the x equals 605, that means log base 4 of 605 is equal to x. Okay? You could do that. And then you could use the change of base formula and say it's log of 605 over log of 4. Right? You could. But I don't want you to, because then if you get in the habit of doing that, you can't necessarily do that here, and you certainly can't do it here or here. Okay, so when we're solving these exponential equations, you're not solving them by rewriting them in logarithmic form. You have a totally different strategy, one that will work for any of these questions. B, you could actually solve by converting it into logarithmic form, but it would be clunky, okay? What do? Well, the problem here is the x, which is the unknown that you're trying to find, is up in what I call an inaccessible level. It's at an exponent here, where traditionally when you're trying to find x, it's on what I call the main floor. It's not an exponent, it's a base. If we know x in a base form, then we can solve this. Well, how can we get that x out of the top floor? The answer is we can take the logarithm of both sides. And I'm taking a base 10 logarithm, and the reason for that is if at some point I want to know the value of my answer, I can use the base 10 button on my calculator, the base 10 logarithm button on my calculator. So how is that helpful? And again, these brackets are not needed, but I like to remind you that you are only allowed to move that exponent down in front if it's part of the argument. Okay? In other words, it's in the brackets, and it's an exponent in the brackets of the thing, of the power you're taking the logarithm of. So this becomes x log 4 equals log 605. And you can see what happens here. We divide both sides by log 4, and you get this. And again, I point this out because some of you might say, well, why would I need, let me write this down first. Why would I need to look at it that way? by taking the logarithm of both sides, when I could have just changed it from exponential to logarithmic? And the answer is because that won't work here or here. Okay. So there's the answer. And if you want to know the value of that, then you can take your calculator and you can take the logarithm of 605. Well, I misspoke, and I'll correct it in a second. You can take the log of 605 divided by the log of 4. We're not actually finding the value. This is where I misspoke. We're finding a decimal approximation of the value. The value of it is log 605 over log 4, period. But as a decimal approximation, maybe for a numerical response question, x is equal to approximately 4.62. Good? Okay. So in this particular case, I think it's a good idea to divide both sides by 8 to begin with. We'll talk in a little bit about what happens if you don't. But if I divide both sides by 8, I get 3 to the 2x equals, and it's at this point in time, actually, where when I divide both sides by 8 and get what I think is 71, I commit myself to dividing by 8. If I divide by 8 and I get 71.385672, I'd back up and I wouldn't divide by 8. Okay, so I'm dividing by 8 because I get a whole number. I get a division with no remainder. Now I can take the logarithm of both sides. Base 10 logarithm of 3 to the 2x equals the base 10 logarithm of 71. And then I can move that 2x out in front. And that 2x log 3 is like me having a times x times b equals some number. And if I have a times x times b, that's the same as a times b times x. So x would be equal to that number over whatever a times b is. The point I'm trying to get across is we need to divide log of 71. We need to divide log of 71 by both the 2 and the log 3. Even though it's not 2 log 3 times x or x times 2 log 3, it's the same thing. And what we get is x is equal to log of 71 over 2 log 3, or, because we can, and we should know that we can, I can bring that 2 back up. And really, from that, are you okay with log of 9 there instead of 2 log 3? Really, I could have saved myself the heartache there and just left the 2 up and moved only the x down. It's not a heartache. It's not a big deal. And if you want to know the decimal approximation of that, then you can, what have I got going on here? Interesting. I guess I better talk about that. So if I take log of 71 divided by log of 9, I get that. That's the decimal approximation. If you want to write it down, you can. If I take log of 71 divided by 2 log of 3, I don't get that. So what's the issue here? No? Do you know?
You're dividing log of 71 by 2 first.
Right. This second thing that I've entered, this is correct, by the way. This, I've said, calculate the following. Right? There's an implied multiplication sign in between the 2 and the log 3. So if you wanted to do it that way, I don't quite know why you wouldn't just move the 2 up. You'd have to put brackets starting at the 2 and ending at after the log of 3. Okay. Any questions with B? All right, this is kind of this is a beast of one. It's not, it gets worse. I shouldn't have said it that way. There's one more type of question that can be even more complicated, all right? But this one is pretty complicated. I cannot write 4 and 3 using the same base, but I can take the logarithm of both sides so that I can move the exponents out in front to the main floor, okay? So this will be log of 4 to the 2x minus 1 equals log of 3 to the x plus 2. And now I can move those exponents out in front. And we've talked many times in this course, I've talked many times in this course about you cannot make those junior high mistakes or those grade 10 mistakes. So for example, when I move this exponent of 2x minus 1 in front, and I get 2x minus 1 multiplied by log 4, if you think that's what we get, then you've lost the thread of this whole narrative. That's not what you get. It's not 2x minus 1 times log 4. It's 2x minus 1 times log 4, right? It's the whole thing times the base 10 logarithm of 4. And then here you're going to have x plus 2 times the logarithm of 3. I do understand that I think most people, especially after you work with this a little while, can go directly from the question to this. And I think you know how I feel about that. If it's a written response, it's nice to show that extra step for the marker. And the more steps you skip, the more likely you're going to make a mistake. So now the question is, how do you get x by itself? And I'm just going to ask you that. Does anybody have any ideas on what we need to do algebraically at this point in time? Because we're used to solving equations that have x's and numbers that look like this. Right? If it looks like that, if we have very distinct terms that have x's and other terms that are just numerical, then we can shuffle the x's to one side and the numerical terms to the other side. But we can't do that here. Does anybody have any ideas? Can you speak up a bit and start again?
Could you do the logarithms? So like the log 3 divided by log 4, and then the 2x minus 1 divided by x plus 2?
You can, but it doesn't go anywhere. You know, definitely, I'm going to write this down because I want everybody else to understand what you said. And it's a good idea because it does move the x's to one side and the numbers to the other. But writing 2x minus 1 over x plus 2 equals log 3 over log 4 still has these numbers and the x's kind of all rolled together on the left-hand side. What we want to avoid is, by the way, introducing fractions. We want to turn it into something like this at the top. So it's a good idea, and I think if you did this, you'd realize right away that it doesn't go anywhere. Then it's like, what do you do? So when you solve these problems, this is going to be the roadblock that most students encounter. And then there's another one. The answer is you have to multiply that out. We have to take that log 4 and multiply it by minus 1, and the log 4 multiplied by 2x. And if we do that, you get 2x log 4 minus log 4. And I mean, you know it's just an analogy. But if you look up here, this term is like this term. It's a number multiplied by x. Whereas this term is like this term. It's just a number. Log 4 is just a number. And we're going to do the same thing to the other side. I just want to, we can leave that. So x log 3 plus 2 log 3. So these two terms are like terms. They're similar terms. They're like having an equation with 4x and 17x in it. And these two terms are like terms. They're like having an equation with negative 11 and 2 in it. So what would we do with this equation at the top of the screen? We would move all of the x's to one side and all of the non-x's to the other. So let's do that. I like to rearrange this to minimize the number of negatives. I think you see that if you move the x's, let me write it down but ask you not to. If you move the x's to this side, and you're not writing this down because I'm about to erase it. So we take x log 3 and subtract 2x log 4, and then over here I get negative log 4 minus 2 log 3. And by the way, there's a lot of numbers floating around here. You have to be very careful about writing things correctly. But I think that looks good. I have 3 negatives. It's better to have fewer negatives. So looking ahead, if I move the x's to the left side, I've got my 2x log 4. I'm going to subtract my x log 3. This is equal to 2 log 3, and I'm going to add my log 4. So the roadblock, the stumbling block, the barrier that most students encounter happens right here. They go, well, what do I do? Well, the answer is you multiply it out and you move everything that has x to one side and everything that doesn't to another side. That looks okay, doesn't it? Okay. Then there's a roadblock. There's another barrier that students will get to and they'll go, oh, I don't know what to do. Because this is different than up here. If I moved the 4x over and I have 17x minus 4x, you know that's 13x, right? So what do we do here? Or what can we do? Factor the x out. And, you know, you could do that here, couldn't you? You could factor the x out and have 17 minus 4 and then go, oh, that's 13. But you don't need to. Whereas here, exactly right. What we're going to do is factor the x out and be left with 2 log of 4 minus log of 3 will be equal to 2 log of 3 plus log of 4. And now we can divide both sides by 2 log 4 minus log 3 and get x equals 2 log 3. These are all base 10 logarithms plus the log 4 over 2 log 4 minus log 3. And that's your answer. If you're going to be successful here, I don't think that the mathematics procedure is difficult, but look at all those numbers. Like you got 2s and 3s and 4s, and some are log 3, some are log 4s, some are multiplied by 2. It's very important for you to double check as you move from one step to the next, and that's what I'm doing right now, to make sure you've written things correctly. Now, you're not going to see exam-style questions with this today because I haven't had time this unit to make any, but if I were to give this to you as a numerical response question, I might give you the equation and say it's equal to, x is equal to 2 log a plus log b over 2 log c minus log d. Okay, it could be that kind of thing. Or I hope you all see how 2 log 3 can become, or can be written as log 9, and 2 log 4 can be written as log 16. So maybe I give you a question, or you see a question where it says x is equal to log of a over log of 16 minus log of 3. And a would be 36, because log of 9 plus log of 4 is log of 9 times 4, which is 36. So as involved as this question is, this one is more involved, and it's because of that 24. That 24 is like that 8 in question B, but we could divide both sides by 8 and then get rid of it. Here, you're not going to gain anything by dividing both sides by 24. All you're going to gain is having the same equation written this way, which in many ways is more complicated because now you have a fraction. And what we're going to do here is going to be helpful for you when you work on the second part of that written response assignment that was on your desk at the beginning of today's class, which is due Thursday. If you want it marked and returned to you before you write your exam on Friday, you can give it to me Wednesday. Okay, it's up to you. What are we going to do here? We're going to take the logarithm of both sides. But we cannot move this exponent on the base of 6 out in front, because it's not a logarithm of just that, it's the logarithm of something times that. What we have to do here is write this as log of 24 plus log of 6 to the x plus 2. And then in the next step, we can move the x plus 2 down. Just for symmetry purposes, I'm not going to move this exponent down until I move the other exponent down. It doesn't matter. You could move them down at any point. So I get log of 24 plus x plus 2 in brackets log of 6 equals x plus 3 in brackets log of 2. And if you were to compare this question to the previous example, C, I guess it would have been, I think. When we expanded it out, we had 4 terms. 2 had x's, 2 didn't. When we expand this out, we're going to have 5 terms. 2 will have x, 3 won't. That's all. There's just going to be an extra term tagging along, that log of 24. So this is log 24 plus x log 6 plus 2 log 6. And I'm just very tempted, as I was processing 2 log 6 in my head, I was very tempted to write log of 36. Because 6 squared is 36. If you are tempted, hold off on that temptation for one more line. Here we'll have x log 2 plus 3 log 2. Double check everything. X log 6, 2 log 6, x log 2, 3 log 2. I'm going to move my x terms to this side. That will give me fewer negatives. Just before we get started today on the practice, I have to talk about what happens if you move it to the other side. And then I have to subtract the 3 log 2. Just double check this, x log 2 minus x log 6, and then I have log of 24 plus I have log of 36 minus log of 8. You know, be very careful here with 2's and 3's. When I move that exponent here and I put it on top as an exponent of 2, it's 2 to the 3, which is not 9. It's 2 to the 3, which is 2 times 2 times 2, which is 8. The really nice thing about this is when I pack these together as a single logarithm, I'll have 24 times 36 divided by 8, and 8 goes into 24. I'll get a single logarithm that can be tidied up quite nicely. I do need to factor my x out. That's my goal. Sooner or later, somebody is probably wondering, do I have to put them together? And I would say, no, you don't have to, but what if the question is designed that way that your answer is written in that form, whether it's numerical response or multiple choice? Am I wrong, or is this 108? It's 108? So we get x equals log 108 over, missed the 6 there, log 2 minus log 6. Any questions with that one? If you want to impress your friends and family and pets, you can factor a negative out of the bottom. If I factor a negative out of the bottom, I can put it wherever I want, but then the bottom becomes log 6 minus log 2, which is log 3, which is even more compact because it's log of 6 over 2. With a negative. Oh, resist the temptation to go 108 divided by 3. You can't do that. You cannot divide arguments for logarithms. Okay, let's take a look at one final example. I see this on diploma exams frequently. This happens to be a half-life problem, and it says that here are 2 different times of the day, and the mass of a radioactive isotope is 150 grams. You should know that this is an application of this formula from your formula sheet. And you should know that B is a half because it's half-life. A is equal to 150 grams, B is 0.5, and P is the length of time it takes to get cut in half. And the first time I saw this question, I thought, ooh, that's pretty dirty. Because I thought you had to do all this algebra to find a half-life and then answer the question. But you don't. The half-life is 4 hours. Because it goes from 150 to 75. If it said, instead of 75, it said 25, then you've got your work cut out for you. And that's a legitimate question. We'll probably encounter it in our review. But since it takes 4 hours to go from 150 to 75, which is cutting in half, the half-life is 4 hours. So our equation will be y is equal to 150 times 0.5 raised to the t over 4. Bless you. A is child's play. Correct me if I'm wrong, but from 9 a.m. to 3 p.m., that's 6 hours. So you're just putting 6 in for t. This is for A. Right, for A, you're given the time and you're asked to find Y. We're just putting this in to the calculator. Six over 4 is 1.5? Okay, I don't know why. Okay, 1.5. So about 53 grams. What B is asking is how long does it take to be reduced to 32 grams? Which means you're going to change Y to 32 in the equation and solve for T. Which we now know how to do algebraically. This would have been a question that I would have given you second lesson of the unit maybe third. And we had to solve it graphically. What you're going to do now is divide both sides by 32. I don't really know what 32 divided by 150 is. Let me figure it out. 16 over 75. Nope, that doesn't help. I mean, you're going to carry all your decimals. It's 0.21 with a 3 repeating equals 0.5 to the t over 4. Take the log of both sides so you can move that exponent out in front and then solve for t. Is that number okay? Okay, I'm just checking. Sometimes we don't need to show every single step, particularly in the lesson. Right, I take the log of the right-hand side, but that exponent of t over 4 gets put down in front. That's the whole motivation for doing that, for taking the log of both sides. So I got to get rid of the 4. I also need to get rid of the log 0.5. And that's going to be my answer.